All right, that's good. So, questions on this chapter 6? Jameson.
Number 1.
Number 1, numero uno. And this was with apply, right?
Yes.
Let's see how this works. All right, apply, there we go. All right, so entry and profit. Paige initially has only the licensed operated bookstore in Bookville. She charges a price of $9 per book and has an average cost of $4. Sells 1,001 books per year. Suppose Paige's license expires and the city decides to auction 2 bookstore licenses to the highest bidder. Oh, government. Occupational licensing. Let's talk about that maybe this time. All right, suppose the relevant variables, price, average cost, and quantity per firm, take on only integer values, no fractions. The maximum possible bid for each license is, and what did the answer have?
3,000.
3,000. All right. And who's got this one under control? Nobody? How come? What'd you try?
I doubled the average cost because there's going to be 2 firms. And then I used that average cost times the demand to get to 3,000 is how I got it.
Okay.
Or I added $2, sorry, not doubled.
All right. You got your work on your paper? Why don't you come on up? Bring your paper up. Lawson, everybody not getting this one. This might be extra credit worthy.
Oh, we'll see. I was just so.
And you can point at it and walk us through your answer, basically.
I was really struggling to find this 6, but I figured that the price was going to go up by a 2, kind of like almost a halfway point because of the 2 firms added. But I just knew that there was going to be a shift in the average cost curve above the marginal revenue, and that would increase the prices. I'm struggling to find.
So I'm kind of hearing you say you plugged and chugged. What's your margin? Is that for this problem, marginal cost equals marginal revenue at 500?
Yeah.
Where did those numbers come from? I'm looking at this. Marginal cost, marginal revenue. So is 500, did you guys get that, or what quantities, or? I'm not sure where you got that from.
I assumed because there's 2 firms, but I knew one would have 501, right?
Okay, so it was in the ballpark of so you just kind of split it.
Yeah.
Okay. And then 3,000 is the max. How did you backdoor that? Because we're kind of backdooring this, right? We're adding, there's going to be a cost of some sort, and what's the most that you'd be able to pay?
Because that would be like your break-even point too with the average cost.
And is it 3,000? It's $3. You got the 9 and a 6 there.
Mm-hmm.
So when you plugged in 500 into your demand equation, you got 9.
Yeah.
Is that right?
Yeah.
Or using the equation? And then there was a 6 here at the average cost. So there was $3 worth of surplus. And then you got the $3 times 1,000 units is 3,000, or you got the $6
I was trying to do
cost.
like a break-even point for like the max, the bidder. Since it was a bid, I figured that it would be a break-even point like for the costs.
Okay. What do you guys comment on this? No clue. Must have got some clue. Jacob, don't remind me after we get done with this problem. So 2 firms cutting in half. I mean, I'm seeing some potential there. All right, why don't you grab a seat, Lawson? Let's see. I want your paper though. Okay, so we got the 9, charges the price of 9, average cost of 4, and 1,001, pages license expires, city decides to auction 2 bookstore license. And she's the only bookstore operator, right? Yeah, the only license. So we're gonna split it in half, identical goods, so the whole splitting thing, we're kind of splitting the market that way. Suppose the relevant variables for price, average cost, take on only integer values. What is the maximum? The maximum possible bid. So it could be less, but so one way to think about the maximum is at what point are they not making money, right? So I think given the limited amount of information here, this was her, or is this what you're doing as a monopoly, basically?
Yeah.
Right? And so at that point, we had $6 at 1,000 would be $6,000 of additional profit above normal, right, with one company. And so with 2, we're really doing is we're creeping up this average cost curve line, which we don't have a function for, right? So does it end up at 6? I don't know, right? So what do we know?
Average cost is gonna shift up because it's going to the 2 firms. Or more.
Average cost would go up. I don't want to say shift up necessarily because we could be, if we look at the average cost of production, if I do 500, I'm just creeping along this existing curve. So it doesn't necessarily shift up. We talked about it shifting up. Maybe there's competition and increased cost because of this or that. But if there's agglomeration economies, it could shift down, right? So if for some reason having 2 of these people operating there and there's common labor pool or some of the other things we've talked about, could actually bring costs down. So there's some competing factors that could happen. So I think for this type of problem, we just got to look at the numbers we have. And what is the economic profit currently?
5,000.
5,000.
500,500.
5,500. How are you getting your?
You said profit,
Yeah, profit, economic profit.
so I took 9 minus 5 and then multiplied that by 1,001.
Okay, so 9 minus 5. Was it 5?
Like, yeah, like,
So the average, she charges a price of 9 per book and has an average cost of 4 per book and sells 1,000 books.
5,005.
So 5,000 and 5, yeah. So the 5,000 with the $5 per unit.
like 5.
The price is 9 and the average cost is 4. You subtract the 2.
Oh,
Price minus average cost.
So another way to think about it is, could the same person or company buy both licenses? What would be the amount that they buy for both? How much would they be willing to pay? Let me put Lawson's paper back up here.
Doesn't it depend what the opportunity cost?
Not really. I mean, the opportunity cost is kind of factored here into this information because we've got opportunity cost built into the average cost curve, and all we know is that there's above normal profits, economic profits of the 5,005. So what's the most that you would pay if you could acquire both licenses? 5,005, right? So then that would leave us at the 5,000. So the answer key says 3,000 if there was both, and why would that be?
Just
3,000.
quantity increase.
Because what?
And the quantity of sales increase.
Yeah, so the quantity is going to decrease, and so economic profit's going to go down, which is the most that we could do. So the most, if they could do it that way, would be 3. I'm not coming up with a good reason why 3,000 is the answer. So I don't think there's really enough information. So the best answer for you guys to do something like this would be to reason it as far as I just did with you, right? And explain some of that. And then try to force yourself to come up with the 3,000. But I'm still coming up with, this would be some sort of estimate. They don't give us anything about the functional form of the average cost. So we really don't know for sure when I get rid of 500 units if I'm up at 6 or not. I think what Lawson did is a good guesstimate that at 500 we'd be at 6, and so boom, I got what the answer key said, 3,000. I mean, to me that's about as good as you could do, but I would say something like, this is economics class, remember, so what can we always do to make something work? Plug and chug,
Explain.
or ask you me. Assume. We assume. So I would say for like Lawson's answer, you could take it to this and say, because I think you did a good job here of like putting it together, you brought it to the 500. If it's the normal shaped average cost curve, it would be cutting in half. But maybe something like, assuming the average cost curve looks like this, then there would be $3 of economic profit that could be bid towards the thing. End of answer. That would probably be the best answer for this one. Because in reality, we don't have the functional form of how steep or how curvy or what that actually looks like to come up with the right number. So, okay, Bryce.
So how did they get 3,000? Is that, are they making assumptions like that?
Well, see that, so the author, I think intentionally, I hope, leaves some of these with just the answer so that we can have that exact same discussion. So that you guys can kind of grapple through it, and that's maybe one possible answer. So making that assumption, that's what we do. That's a reasonable way to think about how this one would shake out. Okay, anything else on number 1? Definitely a tough question, by the way, so yeah, good.
How did you get 6?
What's that?
How did you get 6?
Oh, over here?
Yeah.
That was the assumption part.
Yeah. Okay.
So Lawson just kind of eyeballed it. So in an answer, I'd like to know that you eyeballed it, right? That's the part I'm saying. So I would write something like, I'll give you guys, if you want to write this on your paper, here's what the best Econ college student answer would look like. So here's the other thing that, might not be immediately obvious, but cutting the market in half, is it for sure going to be cut in half? Again, assuming that the firms are identical, the books are identical, blah blah blah, all of that stuff. So, so I'd say something like, assuming the market will be shared 50-50, and the average cost curve function looks as depicted, which is Lawson's picture. Economic profit is equal to price minus average total cost is the $3, 9 minus 6, right? 9 minus 6 is the $3 times the 500. Well, this is the 500 units. This doesn't even give us our 3,000. Because what didn't it say per permit? The max per permit? Okay, well, we're still kind of there. We're back to my, if you could buy both permits, what would you do, right? So that if you had to have 2 locations or something, maybe. So that would be 1,500. This represents the max bid per firm. If one person did both, 3,000 is the max. Kind of a dumb answer, but if we're trying to make the 3,000, because it did say per permit, I think, right? The maximum possible bid for each license. So. You know, and we could kind of play it. There is advantages to having one big store that's doing 1,000 versus 2 smaller stores, right? If they have 2 licenses and part of the requirements are it being separate. Okay, other ones on this set of questions? Chapter 6?
Okay,
5. All right, 1 city size. So consider a consumer region with only 2 consumer goods, tattoos, per capita demand 3, manicures, per capita demand 6. According to Mr. Wizard, if my assumption is correct, all consumer cities in the region will be identical. Mr. Wizard's assumption is, and what was the answer?
M will double T.
What is it?
M will double T.
M will
Will double T.
will double T. Okay. So this is apparently tattoos and manicures, right? Okay, what do you guys think of this one? That makes sense? How did you justify it? I think is the important part here. What is the assumption? What's kind of going on here with the model? We got a consumer region, 2 consumer goods, the high demand good and the low demand good.
For every tattoo shop, there's gonna be 2 manicure shops.
Okay, 2 manicure shops for each tattoo shop. But why?
6 manicure, demand for 6.
And you forgot to tell me after that problem.
Yeah.
Remind me this time. What now?
The demand of 6 is double the demand of 3.
Okay.
2 manicures for 1 tattoo.
Okay, so on a per person basis over that time period, Jameson? Okay. So kind of explaining what per capita demand is, putting it into words, I think is good. So, and then the one thing that's not obvious here is that it's really over a certain time period, if you want to think about it that way, right? There has to be a time like per year, per month, per day, whatever it is. We have double this than that one. And so with that, we can have the 2-to-1 assumption. What other assumption would be needed? We did some other things with the assumptions of these goods. I don't know if you remember, tattoos and manicures. Are those complements?
No.
Substitutes? No relation?
No relation.
No relation is the assumption of the model, right? So we might get some different results if we started allowing there to be some complementarity, that they're used together, or maybe substitutability. So consumers consume these in like fixed proportions. So let me pull that up real quick here. Chapter 6. It was at the beginning, and this is just kind of one of those little details you might not, without doing a little digging here. Okay, so there's demand for large city. This is not the thing I was looking for. This type of stuff. So central place, fixed population, ubiquitous inputs, uniform demand, the substitutability, no complementarity around goods. So those are some of the assumptions that we can claim that it would be 2 manicure shops for every tattoo shop. Okay, other ones on this chapter 6?
Can you go over 3?
Absolutely. Pizza and sushi. Suppose pizzerias and sushi bars experience roughly the same economies of scale with a common minimum market size of 200,000 meals per year. The per capita demand is 20, and the per capita demand for sushi is 4. Suppose you move from a city with population 20,000 to a city with population 60,000. The number of pizzerias will change from, so what's the answer?
2 to 6.
2 to 6. And does that make sense to you guys? With the per capita demand, all the assumptions? And then the number of sushi restaurants will change from 0 to 1. Yeah, so we get above the spot where we might get some sushi restaurants. So, so I had a business partner that had a policy that I have now broken. He said, never eat sushi in a town less than 50,000. Never eat sushi in a town less than 50,000. Why?
Because they got to make it cheaper because the demand is low.
Possibly cheaper.
Food poisoning.
Food poisoning, yeah. So if you don't have the per capita demand high enough, you're not turning over the raw fish. And so they're going to be the ones like, oh, we haven't sold this one yet. Let's have a sale. Get rid of this one. It's kind of looking a little skanky, but I can trim it off or something, right? Now, I say that because Ottawa's about 13,000, and I like to go to Nagoya, and I will eat sushi, and I have not been sick. But some of you may or may not know, Nagoya is affiliated with a Lawrence one. So they can rotate their product a little faster than some other places. So that's what I've been hoping is the case. Fingers crossed that that'll be true. But that was my friend's old assumption. So, all right. Any other ones on this? Did that? I can't remember who asked this. You did, Lawson? Did that answer your question? It's all with that fixed proportions.
I don't know why I struggle to find the answer on this one.
I'm still
And you're still, okay. Who wants to come up? Bryce, I saw you. Carlos, I guess I saw you in a second. But go ahead, Bryce. Yeah, you bring your paper up there, throw it on that screen. And you have to look to see if it's capturing what you want to capture up here. Okay.
So I did like the,
Well, I divide.
Can you lower it?
Is it? It's this
It's
one, right?
number 3,
Okay.
yeah.
You got all your little
It's
lines you
all-
wanted? Okay.
So 20,000. So this is for the pizzeria.
Yep.
So 20,000 times, which is the population, times the 20 meals per year.
Which is the per capita demand, right?
Got me the 400,000 divided by the 200,000, which is what a single restaurant could produce in that given time. Gave me an answer of 2 pizzerias at that population. And I just did the same thing. So when the population goes up to 60,000 times 20, meals per year. It goes up to 1.2 million divided by the 200,000. That would give you the 6 pizzas.
So the proportions end up staying fixed.
Yep, and then it's the same thing. It's just the 20,000 times the 5 meals a year gets you at 100,000. But it would take 200,000, so you'd only have half of a restaurant, so it wouldn't be profitable.
Right,
to do
half the
so.
restaurant doesn't work. Okay.
And
Questions for Bryce? You guys thought were. All right, good. Anything else on this chapter? Or you had a question? Oh, yeah, about time, Jacob. Thanks for Tyler having to save you again. So, how many of you have signed up for game night? Show of hands. I got a couple. So, Jacob, what is the game about?
Econ is a game where you trade amongst your peers to try and build your city.
Build a city.
You make roads to connect to collect resources, and every time you roll dice, you can get resources, or you can not get any, depending on if the other people get it or not. There's a blocker or robber. If you move it around, you can steal resources from other people.
Decent amount of strategy.
Yeah, you can make trades with them as well, and
Yeah, so it's kind of a cool economics game. You do trades, there's fixed resources, but then basically there's win-win situations with the trades, right? So just like we do with trading, that you have something you don't really need that bad because of your circumstances, and you can trade with another, and you build up a city. So spatial economics written all over it. I hope that all of you will make every effort if you can to be there. It is extra credit worthy, so if you can't make it, it's not the end of the world, but it'll be a cool game. You don't have to know how to play. What was our ratio right now? How many? 18 people knew how to play out of 70?
yeah.
So we're almost full, too. So you need to jump on that QR code if you're interested in doing it and sign up to play. So,
Russ.
any questions?
Tuesday at 8, right?
It's 8, Tuesday at 8. If you got to work or something, I know that happens, but I just wanted to put a extra plug in that it seemed really relevant to this class since we're building cities. All right, was there any other last questions on the homework for chapter 6? All right, so we're continuing on with chapter 7. And you guys had homework, if I remember correctly. So how did that go? So let's see, let me get my pen. Don't fill out anything right now. I'm just going to come around and see if you did your homework or not. You either did or you didn't. And it probably won't be a grade changer, but you never know, do you? You just never know. So, homework. So, pencils down, just point to your answer that you did the work, that you got it, or just tell me that you didn't or you did. Actually, let's just have you point and verbalize. Did you do it?
I did.
Did you finish it? Did you finish the problem is what I'm asking. Because we started it in class. Did you finish it?
Yes.
Okay.
Which one?
Julian's a no.
Was it senior ones?
Carlos, did you finish the problem?
No.
Alright. No big deal, it's just extra credit. Bryce, did you finish the problem? Like, don't finish the problem right now, people. Alright, did you finish the problem? What is that? A yes or no? You either finish
Answer, I just don't know if it's right.
I don't need right answers. I just want that you came to an answer.
Yeah.
Oh, that's all we need. Yeah. All right. Gabe. Yes. And Jacob is a yes. Tyler is a yes. And is a yes. Jameson's a yes.
I didn't hear.
Galen is a no. You were kind of gone, yeah. That's right. I'll let you make it up. You did have an excused absence, right?
I don't have an excuse.
You came to something. Okay, that's all I asked. That's all I asked. You came to something. Zeke came to something. Okay. Lawson, did you come to something? Okay, and Jonathan?
Yeah, something.
You got something. All right. All right. So now we got absent. Okay. So, Julian, number between 3 and 7. 1, 2, 3, 4, 5, 6. Gabe, you are a lucky contestant. Come on up. Explain your answer. Whether it's right or wrong, doesn't matter. Just kind of work through what you got. What problem was this again?
Number 2 of the apply.
Number 2, okay.
What was the question? I don't even remember the question.
Yeah, I can.
I just had the function.
Oh, so you did it right away? Okay. Let me pull it up here. Oh wait, I got it right here. Oh, this was with the 11 million workers, right?
Yeah, it's number 2 of chapter 7.
So number 2, chapter 7. So it's a regional economy. Let me go ahead and put this up here. Right here. A regional economy has 11 million workers and an urban utility curve of that, where N is the number of workers in millions, initially at 11 million, and workers are in a single city. Suppose the regional government says there's going to be 1 million workers in one and 10 in the other. In the old city, predict what's going to happen to the distribution of the population over the 2 cities. And then we get into the subsidy thing as part B. Subsidy to the residents is S 12 minus N, so that the utilities in one go to the other. All right, so that was the problem.
So I had like the function that they gave us, and I just started plugging in the populations from
Okay.
to the cities and getting the utilities, and then I started working my way to like the equilibrium point, and then I got to 5 and 6 million, but that would be still like the utility was different, so I ended up it would be 5.5 million.
5.5.
Equilibrium point.
Okay, did other people get 5.5?
That is right.
Or what'd you get? You did?
Yeah, it depends if you count integers. That's how
It depends if you count what?
the integers. Like
Oh,
the
integers.
For the,
Yeah, no, we can go. Yeah, we could go in between. So yeah, it was in the millions. So okay, yes, that is fine. So other people got that. I just want to know if I don't have the answers, by the way. So we're just kind of winging this thing. All right, Gabe. So next part 2.
Yeah, I don't have part 2.
What?
Yeah.
That is the most important thing. All right, maybe we need to be more specific here. Let's go back down the list of the yeses. Part 2 is what I wanted you to work on. Who needs to change their answer? Who did?
Very good.
We're changing the answer? No, okay.
Yeah, and we gotta do part 2.
It's a no, okay. Fox is a no.
Subsidies.
Okay, McKenna's a no, Andrew's a no, Jason's no. So you guys did the easy part of, now I understand. Are you cheating?
No.
You
I
did part 2?
something.
Okay.
Well, part 2.
Yeah, you did something. You did not do part 2.
No, I didn't get.
Easy come, easy go. You did not, both you two did not do part 2. Andrew, no. Okay, so now we're down to Zeke. No. Alright, little adjustments to the record keeping.
Little.
And Jason was a no. Okay, so now we are down to Carlos being the only one with extra credit. He's pointed to something on his paper. So, oh wait, you said no before.
Yeah, because I didn't know that was the whole problem. I didn't remember the problem, so I didn't remember what I did. Then now that you show up, I figured out that I.
So you did work
I
it.
did
So
work
you
it.
do deserve. Oh, so you're actually changing from a no to a yes, ironically. Okay, got it. So go up there. Take the stage. Carlos from Colombia, the only one.
Oh, I'm not sure. Okay,
No, you don't have to be sure as long as you tried something.
What?
Yeah, go up to the projector. Just put your paper down.
Under the green things.
Underneath here.
Yeah.
Haven't you been up here already before? Okay.
No,
yeah.
never.
So now you just have to kind of
I
align your paper.
I told you that I did something, but I haven't more in my mind, like the answer now.
Okay. Oh, you
Can
want
I-
you
can
want a
I-
marker?
Or no, I can do it here, bro.
Okay. Oh yeah, you can do it on your paper. Yeah. What are you trying to do?
So basically,
Oh.
it's CD. You know, I know.
Okay.
I remember it something.
So, let's have you all work on it with your buddies now. That you didn't
I
do.
should do that.
Now, I want to see what you did just to verify you deserve extra credit. Show me what you did do. Like, you couldn't even verbalize crap there, so I'm not convinced. What did you do? Okay, so that's the subsidy formula. Though. Okay, he did do something, folks. So he at least had the subsidy formula down. So I'm gonna let it stand. So you guys figure out an approach here. We have a subsidy, so they're trying to encourage. We'll be talking a lot about this in this book in general. So the government is trying to give an incentive for people to come. Suppose the regional government provides a subsidy to the residents of the new city. The subsidy in utils and units is S equals 12 minus 2n. That is 10 units, 10 utils in a city with 1 million workers, 8 utils for 2 million workers, and so on. So it kind of goes down, notice. Predict the new equilibrium distribution. Basically, those of you like Gabe did on the first schedule, you're just going to be modifying those numbers, right? If you're in the new city, you get this extra bump. But it depends on how many people are there. No, it's not a negative. It'll cap out. So the most it could, yeah, you can figure out this. Well, let's all look at it together. What's the population that wipes out the subsidy? 6. So 6 million is going to be the max subsidy, and you won't get it negative, get taxed or whatever. So it's just the subsidy is dead after that point. No, you can break it into fractions. I mean, you don't have to. I mean, whatever answer you come up to. So
Yeah.
from a dynamic perspective, what's kind of going on? Is it making the movement faster in a way if we had a time dimension to it? Like, what does the subsidy really do? Does it make it more attractive or less attractive?
Less. More.
More, right? So does that mean people would move there quicker?
Yeah.
So if we added a time dimension, which by the way isn't part of the model, but just kind of mentally thinking about it, if there's a subsidy, it's going to make the movement to people probably happen faster. But as they go to the city, of course, the subsidy's declining, and then it just gets us to equilibrium probably faster, is one way to think about it. Okay. So did anybody do equations with this one? Okay, and so what did you solve with the equation? What did you come up with?
So I plugged in the utilities for 4, 5, and 6 into the subsidy equation, and then I added the utility from that subsidy equation into the previous equation that we had.
Okay, so you didn't solve for n. Did anybody solve for n? And so what did you end up getting? Is the answer 5.5? So how did the 5.5 shake out again?
I did the Boston did it, just found that with 6 and 5, it's an actual equilibrium, so then we gravitate to it.
Okay, so between 6 and 5 is where you thought there'd be something, and that's kind of what happened with yours, Gabe? You're thinking it's going to be somewhere in between there? Okay. All right, any last questions on that? Has everybody got at least the gyrations right or down? Okay. Yeah, good one. That's funny. That is hilarious. Let's see, workforce, A, B. Okay, yeah, let's do another problem. I couldn't remember if we needed to do the other part of this chapter yet or not. So 2 innovation cities, this is number 4. Consider a region with 2 cities and a total workforce of 24 equals A plus B. So basically there's 24 in the workforce, and A is the workforce in city 1, and B is the workforce in city 2. For the negatively sloped portion of the utility curves, we get 480 divided by A for the utility in A, of workforce A, and 240 divided by B. Illustrate the regional equilibrium, including the values for the workforces of the 2 cities and the regional utility. So just to refresh you from yesterday, that was, so wait, I don't even have that open yet. That was kind of this stuff with growing and shrinking cities. Maybe I'll do something like this one. So why the negative slope? So cities can be too large in the sense that in this city, utility would be the highest right here at a population of 3, but the city ends up growing to 6 million. And this city is at 3 million people at point M. That's the utility curve for that city, and same thing here. So we're on the negative slope of the utility curve for each one. And so what was the general gist of this model of why that's stable? Why is it a Nash equilibrium? Nobody wants to go, because if I leave here, everybody who stays here just got happier that I left, right? Because I was causing congestion. But then when I go over to this city, I'm adding to this city, and we're all not as happy. So I would not want to make that move, right? Or on the flip side, if I was here, I'd move here and get back to equilibrium. So the utility levels are equal on the negative slope, and it's a self-correcting thing that we get back to it. Okay, so then back to this problem. They got two cities, A and B, and this is the function for the utility curves. So you guys work together and try to come up with the regional equilibrium, including the values for the workforces of the two cities. Answers.
16 and 8.
16 and 8, yeah. So A is 16, B is 8. So move on to the second part.
That's what I did. Well, I did.
So I don't know how you guys did it, but I just did, you're going to have equal utilities. And we know that the equation to solve for B is 24 minus A. And so then you can plug it in, plug and chug, solve for A equals 16. And then if A equals 16, B must be 24 minus 16 equals 8. All right, get to the next one. Suppose that a technological innovation in the first city shifts the utility curve upward, so along the negatively sloped portion of UA is 720. Illustrate the regional equilibrium for the values of the workforces in the two cities in the regional equilibrium. 18 and 6?
Yeah.
Because you're basically just reworking it, right, with the 720. Okay. So conceptually, does anybody have any, did everybody get that? Just kind of replug, basically do what I did with the new one. Let me show you the section that this is on with kind of the technological progress conceptually. So both cities, in this model, this is different than your problem you just did, but imagine there's two cities of 6 million workers, and one city has the innovation, just like you just did. So what does that look like? It's going to shift the utility curve up. And so now we're at points I and J. One city is at I, and the one with the new innovation is at J. And what's going to happen next?
I going to start moving to J, causing it to go down, and I to go up, and start to equal out.
Good. Yeah, and so now we're just setting the two equations equal to each other. So J moves to the right. People start to go to city J. I goes the other way. And so we end up with S and B being the new equilibrium points between the old city without the innovation and the other city with. Now there's kind of a cool result here. What is it? We got the one city that's the hotty-toddy, innovative Silicon Valley city. And then we got the old fart city. But what ended up being the result of the new innovation?
Everyone's happy.
Everybody's happy, right? So happiness rose for both the old farts and the new innovative city. So that's kind of a cool result, and that's the intuition that we get when we look at the back in principles class of the production possibilities frontier, right? If there's an innovation in pizza, do we get more beer? The answer is yes, because resources can be reallocated so that we get potentially more of both goods. Yeah, Bryce?
So, if like taking this and like applying it to like the real world, what about like cities like Detroit where people like maybe they're in poverty and can't move to new places? What would that do to? Because where you don't have people who are moving in because it'd be lower, but they're also not moving up.
So you're saying there's no happy people in Detroit?
I'm not saying there's not. I'm just saying.
No, but the reason I say that is that what happened in Detroit to real estate prices? They go down. What happened to congestion on the freeway in Detroit? They went down, right? So yes, there's going to be unhappiness in different ways, but the point of the shrinking city is that some of these other elements are going to offset some of that, potentially allowing for other happiness. Now, so to get into the nitty-gritty details, I can't find a job and this and that, or well, eventually that transition goes. So whether they can't leave Detroit or they won't leave Detroit are two different things, right? They probably can, they just don't want to, because at the end of the day, being close to family and other things, other considerations make it better for them, they think. Of course, there's always uncertainty with that too. Okay. So let's backtrack here. Okay, so there's where we were. So the other area the textbook goes into is just what the real world looks like with the size of the populations. And so there turns out to be kind of this empirical anomaly that they try to reconcile. And that anomaly is that there's one big city, and then there seems to be a relationship with the next biggest city, the next biggest city, the next biggest city, and it tends to follow this curve in terms of recognizing the population and the ranks. So the biggest city, the second biggest city, the third biggest city, and it wouldn't necessarily have to be that way, right? It could be that the population of the second biggest city is here, and then the third city's here, and here, and here, and here, and so this relationship looks like this. But what we find in the real world is that it looks like this in multiple places. So there's kind of this non-linear relationship. And so economists have tried to kind of figure out that little puzzle and also test to see if it's true that there's some sort of simple relationship between it. Okay, so locational equilibrium is what we've been working on. Nash equilibrium says there's got to be equal utility across the sites. And that gives us this. This is just rehashing what we did already, so I'm kind of skipping it. Okay, so here's the rank size rule. So there seems to be this relationship that maybe we could estimate. If the largest city is rank 1 and has a population of 12 million, then the second city seems to have 6 million. And the third city ends up having the 4. And that's kind of trucking down that non-linear path is the empirical evidence that we see. And what's going on there? Is that something we can count on or not? Or is it some sort of underlying truth? And so economists have tried to estimate whether that does actually work. And it turns out to be pretty close. So this is some work from 2005. 29 different studies of different metropolitan areas like that, where you've got the one big city. And the relationship here is the rank. So C is a constant equal to the population of the largest city. So that would be if it was the 18 million city or the 12 million city, whatever the biggest city is the constant. And then the population of a lesser populated city is related to the rank, which doesn't make any sense on the face of it, that the second biggest, the third biggest, that's what we mean by the rank. And so then if that's the case, then basically if the biggest city is 24 million, it's the second biggest city, 2 times the population of it is going to give you the second largest, of being the 12, I guess, those numbers I was doing. So B is the test variable. So anything raised to the 1 power is what?
That value.
Is that same value, right? So a 1 up here means that the rank size rule just collapses down to n times that. But maybe that could be something different. And so what they find if they run real world data, that they get some estimates of that are pretty close to 1. So if we do this rank size population thing, if we have 19 million in Tokyo, what's the next largest city? In Tokyo, what is the predicted size of the second largest city in the region near Tokyo? I'm just trying to track if you guys picked up what we were doing with the rank size rule.
Probably like 5 million or 4 million.
5 million, 4 million, no. It'd be half of that, right?
I was thinking
Yeah.
exponential.
So that's all they're doing is they're just saying that would be the way we test this. So then we go to Mexico City and it's 16. Is the second biggest 8? Is the next biggest, right? And we just kind of see if there's a pattern. Santiago, Chile, it's only 4 million, so the next biggest city would be 2 million. And we just kind of see if that's true. So that's some of the data that they're running. And so they end up having 1.09 is what they estimate after checking the relationship. So basically, the function is a line that looks like this. And so when we test the data, some cities are a little bit off of that, right? And some are close, but 1.09 ends up being the answer, which isn't too bad. And that is, there's different ways of defining the boundaries. So that first study did a political city. And so what defines the boundaries of Ottawa? The city, the government. It's kind of by discretion, right? Or there might have been development or something else. So when we talk about an economic city, What is an economic city up in Kansas City? The whole metropolitan area, yeah. So when we think about people might move from one town to the other, there might be a mall in one city versus the other, and you're of course going back and forth, right? So in terms of economic activity, we can define it differently. And what they found was that when they defined the places that way, it's actually much closer to the rank size rule. All right. So then we got this. I kind of went backwards because we did that problem. Innovation and income. So that was the shift up. Anytime there's a utility gap, it triggers migration. So at the beginning of the chapter, we were trying to figure out what makes economies grow. So human capital, give that a read. So we think about labor skills and other things. How can we measure this? Human capital and economic growth. Is there a connection between increases in human capital? Do you guys agree that your gut feeling is, oh, well, if we have people that are more educated, more skilled, then the economy should be growing more? Well, how do you measure what's inside people's brains, like this human capital? How can we measure that? Okay, college degrees, good. So that would give us an objective measure. Now, is that a perfect measure? No, right? But how many college degrees are in this area? How many advanced degrees are in this area? So we could look at the level of education within the population. So in Ames, Iowa, where I did my graduate work, it was the second largest, and I think it might have even became the first, but per capita PhDs in the nation in Ames, Iowa. And the reason for that is we had Iowa State University. It's a town of about 60,000, let's say now, roughly. But you got a 30,000 student population for Iowa State, which does a bunch of research, right? Then you've got the National Animal Disease Center, and you've got the National Veterinary Services Lab, and you had the DOT, the State Department of Transportation, which not necessarily have a lot of PhDs there, but there was a number of federal agencies, including Iowa State University, all in Ames, and so we had the largest per capita PhDs, second to Boulder, Colorado, and I can't remember what's over in Boulder besides the university, but so the highest per capita PhDs there. So that's just one way to measure it. What is the mix of people? So here's one way that they can tease that out from a couple different studies. Wage benefits increase 1% in a city's college share. So number of school dropouts, high school graduates, college graduates. And so what's happening to the average wage of everybody in the city? It's saying when there's a fraction more of college students, right, or from the college share, when that goes up a little bit, wages tend to go up. So that's one way to measure the benefits of higher human capital in a place. And then this one they found if they're located in places with researchers like stars, like superstar researchers that pump out a lot of stuff in the biotechnology area and other places, that can happen. All right, so back to the problems. Number 6, rural versus urban development. In the initial equilibrium of a region's workforce of 24 million is divided equally between a city and a rural area. The initial common utility level is 50. The urban utility curve peaks at 8, and the population range of 8 to 12. And in the population range 8 to 12, the slope of the utility curve is 2, rise over run. The rural utility curve reflects mildly increasing returns to scale, In the population range of 12 to 16 million, the slope is 1. Suppose the nation invests in rural infrastructure, bringing Wi-Fi and 5G and whatever, which increases rural productivity and shifts the rural utility curve up by 3 units, 3 utils. Illustrate the implications on the regional economy, including the values for the city population, the rural population, and the regional utility. Ooh, that's fun. Okay, why don't you guys work on that one?
Wait, so is it like a different shape? Why is it, because it says the first 8 to 10 to 12 is negative 2.
That's the slope.
Yeah, so would it be like, instead of a, this shape, it would be a U?
Well, it's the same thing with the utility going up, and it's telling you where it's at that level what the slope is. So the initial common utility is 50. So at this level of 50, the urban utility curve peaks at 8, and in this range of 8 to 12, the slope is negative 2. So you guys work with your partners. That's all I'm going to say. Draw some pictures. Have fun.